I'm going to try and like get my thought processes out. So let's just go to a whiteboard and clean whiteboard and just draw up a bubble sort and just try and see what we've got to do. So when we've got our list of numbers, small list like that, the way that bubble sort works, remember, is we want to compare pairs and we want to move down the list comparing two items at a time. So we've got to reference two positions. Okay, so we want those two as a pair, then we want those two as a pair, and then we want those two as a pair. Okay, so we've got to go down the list. If we do a swap, we've got to pass again. We need to do a pass. So one thing I'm going to need to, I don't know, I think the pen nib's wearing out. If we do one thing we've got to keep track of, so we need to know, have we swapped? So one thing we need, and whenever we want to keep track of something like that, the best way to store that data is using a Boolean value. So first thing I'm going to whack in here, if I can get this to flip back to Visual Studio, I'm not messing with that. I'm going to create a Boolean and I'm going to call it swapped. I need to set an initial value to it. So I'll come back to what I'm going to set that to, but I want to like make sure that I always do at least one pass. Okay, so I always have to do at least one pass. So when I'm looking, I'm saying to myself, right, I've got to do it at least once through it. Okay, because I don't know whether the data is ordered or not. So I've got to at least do one pass. So I've got to force this to happen, and I want to keep doing this until I haven't swapped. So not swapped. So actually, that's telling me that we keep doing it. So until a condition. So we want conditional control of the loop that tells us. Now, always when I'm thinking about that, I'm looking at a while. A while loop is a condition. So while condition is true, do the instructions in that loop. Okay, so that's what I'm thinking. I'm thinking, right, I want a while loop here, controlled by this swap value. So let me go back to my code. So let's whack in a while loop. I don't know whether this is in the right place. I don't really give a monkeys. So I'm going to say while we've been swapping. So I'm going to say while swapped, and I'm going to do some stuff in there. Right, now Visual Studio's moaning at me because it's saying I have not set a value for swapped. It knows I haven't done an assignment because it can look at the code and it's doing a semantic check and it's saying, hey, you know what? You haven't assigned a value to it. There's nowhere where I've seen an assignment operate. So I'm going to have to put something in here to stop it whining at me. Right, so if I want to force this to happen, what I should do, my initial value for this should therefore be true. And that'll force the loop to happen once. Now you could argue and say to me, well, actually, you should do a repeat until loop. And I could do that if I wanted to. But traditionally, we always use a while loop, weirdly, for bubble sort. But you could do it with in C#, that's called a do while loop. You put do at the top, so something happens at least once. And then you go round and round and round and you check at the bottom. So I might mess about and show you what the algorithm the code might look like if I use a different structure. Okay, right, so yeah, I've got to do this. Now, when I start a loop, so when I'm looking at this list that I've got here, I'm going to assume if they're in order. So if I had a list like this, so it's all about examples. So if my list was already in this format, 2, 4, 7, 14, when I pass along it, I won't have swapped. So before I start searching across this array to see if I need to swap any values, I need to make sure that I indicate that I haven't swapped anything yet. So when I make a new pass, I'm saying to myself, hey, hang on a minute, you haven't swapped. So let's just go back to my code. But here you can see in my code I've said, oh, swapped is true. So the first thing I need to do when I get into this while loop is say, like, I haven't processed anything now. So let's assume we're starting from scratch and we haven't done any swap. So I'm going to set swap to false. Okay, so I'm going to say, right, well, I don't know if I swapped. I'm starting with a clean slate. Let's just go through it and see if we do a swap. So if at some point we have to do a swap, we're going to need to set swap to true. Say, hey, we swapped. So that's in the back of my mind. So I need to think about that. Right, so back to the data. So I need to create a loop that starts at position 0 and compares 0 with 1. Then moves on, compares 1 with 2. Compares. So I need to be able to generate these numbers, 0 and 1. So I'm just using this example. So let's put 0, 1, 2, 3. So I need to, that's my first set of comparisons. Whoops. Then I'm going to compare 1 and 2. Then I'm going to compare 2 and 3. And then I need to stop. So I've got 4 items in my list. So I can ask how long the list is and I can get 4. And I want to go and generate a sequence of numbers, 0, 1, 2. So I could use another while loop to do this, but actually because it's a set of numbers and the 2 is related to the length of the list. Okay, so 2 is actually 4 minus 2. So the length of the list. So I'm looking, oops, you can't see that. Hang on. Let's move my move me. Up there. So I'm looking at the length of the list to generate this sequence. So starting at 0 and go up to 2 less than the length of the list. Now normally we just do -1, but this is a good case for where this is a different number to that. So let's go back to the code. So I'm going to create a for loop. Don't know whether this is in the right place yet, so I'm going to say for. I'm going to use Visual Studio's snippet. So I'm going to go tab. So whenever you get those little empty squares with the little dashes at the edge, that means you can put a snippet in. So it'll build the for loop for me, puts the braces in, and puts all the other things. So I'm just going to use I for this. It starts at 0. That's nice. I'll keep that. So the length of it is going to be list.length -2. The increment's there for me already. Okay, so that's my for loop that will generate the numbers 0, 1, 2. But I also need to generate these numbers, but that's just that value plus 1 each time. So that's I plus 1, I plus 1, I plus 1. So I need to just do some comparisons. That's all we're doing. We're just comparing two values. So we compare using if. So we're going to say if list at I, so the first item, and we're going to go ascending. Okay, so if the thing on the left, if that is greater than the thing on the right, so I'm going to say I plus 1, so that gives me the item on the right. So if you look at this, if I is 0, we get to this one by saying I plus 1. Okay, if I was 2, so if I was there, we get to 3 by saying I plus 1. Okay, so the 1 to the right, and this is quite a standard thing because we're processing an array. If you want to move right, it's +1. If you want to move left, it's -1. Okay, just like we saw with the insertion sort, we decremented. So in our code, this will let us do the comparison. So we're saying, like, which one's bigger? Is left item bigger than right? Because if it is, then we're going to move it. So at this point, we're going to say, oh, we need to swap them. So actually, the thing that I was thinking about earlier, where I said, right, if I have to move position, I need to set swap to true. So I'm going to say swapped equals true. I don't know how to swap yet, but I'm not going to worry about that for a sec. So let's just have a look at what logic we've got. If you want to ask any questions in the chat, just ask. Okay. Right, so I set a boolean up called swapped. I set it to true. This while loop is controlled. So while swapped is true. So while the condition is true, it's a boolean, so it's a condition on it. So it isn't a condition you have to test. You don't have to put this, even though I see this all the time from students. It's already a boolean value. So you don't need to make a comparison to get a boolean answer because it's purely a boolean value. So you don't need to do that. So I then say, right, well, I'm going to do a pass. And I'm going to say, right, okay, let's assume we've done no swaps. So I set swap to false. Hang on, take a drink. Then I say, right, well, I want to run down the entire list, but I want to stop. I'll find the whiteboard in a minute. I want to stop at the second to last item. So the second to last item in a zero index list is going to be the length of the list minus 2. So that's what I set up. Okay. Right, now I can put my code in. So we keep incrementing I. So we start with 0 and we walk along and do this comparison. So we found that the item to the left is bigger, so it needs to move, swap round. But how do we do a swap? So let's go back to our whiteboard and think about how we swap two values. So I'm going to give myself two values. Doesn't matter. So I've got 15 at this position. And I've got 10 at this position. At position 3. And I want to swap. So I want the 15 to go there. And I want the 10 to go in there. Okay, so let's call this list, because that's what we're using in our code. So I want to make, so I could do this. I could potentially go list 2 equals, remember that means assignment, equals the item that's at list 3. So if I do that, that will give me a 10 there. But I've now lost the 15. So in order to do this, there is a really clever way of doing this, but I'm not going to show you that. I think I left it in the algorithm, on the algorithms page. Right, so if I do that, I've now obliterated the item at position 2. So what I need to do before I do that, I need a temporary value. So I need a variable where I take a copy of what I'm about to overwrite. So I've got a copy, so that's fine. So I've got in temp 15 before I do the copy over. So I've now obliterated it. A bit like in insertion sort, where we have to keep a copy of the key for the same reason. What I then do, I need to put temp into there. So place the 15 at position 3. So I'm going to say list 3 equals temp. So you can see there's a sort of symmetry to this. So this is what we would call a standard swap. Okay, and you'll see this, and it's it's often when you're doing sorting algorithms and you want to get some metrics and you want to compare a different set of algorithms, that you might create a function called swap so that you can log how many times you've swapped. Okay, so I need to have this sort of mechanism. So I've got temp equals the first position, overwrite that first position with whatever's in the next position, and then that next position then can have the temp value put in it. So let's have a look. Let's go back to our code and let's see if we can do this. So I'm going to create a temporary variable. So I'm going to say int temp. And remember, in languages like C#, most of the C-based languages, we can create a variable when we want it to exist. It will only exist within this block, and then it'll get destroyed. Okay, so it doesn't matter that it looks like we keep recreating it. Right, so I want to move this item across. So if I'm going to copy across, I need to make sure I make a copy. So that's what I'm going to do. So I'm going to take that value and store it in its temporary variable. That now means that list I is available to overwrite. So I'm going to say list I equals, and then I want the one that was to the right. So I'm doing this swap. So it doesn't matter which order I do it, as long as the order is governed by which one I've made a copy of. Right, so I'm going to now say just, okay, let's get the other one and move it into that now vacated position. And once we've got that, so whatever was on the right is now on the left. And then I can say, well, the one that I saved, let's put that in that space at the right. So that's our standard swap. I don't need that blank line, so I'm going to tidy that up. Okay, and effectively that is the end of bubble sort, but we've got an inefficiency. One of the things about bubble sort is that once you've found the big, we're assuming we're doing ascending here. So when we've made that first pass, the biggest number is always going to be at the end. So if I add this data set, so if I had 15 at the start, worst case scenario for bubble sort reverse data, it has to swap so many times. Eventually, so these will swap, and you'll get that. So I'm just going to run through that pass. These will then swap. So you end up with 13, 10, 15, 9. These will then swap. So you end up with 13, 10, 9, 15. So we always end up with that anchored at the correct position. Okay. Right. So actually, when we pass through this again, instead of going 0, 1, 2, we actually only need to go 0 and 1. We can reduce the length of the list. But if we look at our code, it doesn't have the capability to do that, because the next time we come to process, it's always doing list length minus 2. So I've got to change this. And I can do this by creating a variable, and I'm going to call it process length, and I'm going to make that equal to, so we have to do the full pass to start with, so I'm going to take that and I'm going to say, right, okay, I'm going to do that. I'm going to process the entire length. So I'm not breaking anything, and this is going to work exactly the same. I should really capitalize that L. Let's just do that. Use camel casing for my variables. Right, so I haven't broken anything. I've just said, well, let's stick it in a variable. Let's stuck it in a variable. Work it out at the start. Right, so every time we do a pass, the length that we need to process needs to be reduced by 1. So what we've actually done, just by making that simple, readable change, and you making use of a variable, we said, right, if we get down to the bottom, we should have anchored the next biggest in place. So why don't we just say process length minus minus, reduce it by 1 each time. So eventually it will get down to nothing, okay? And we won't have had to do any swaps. And that is it. That is bubble sort in a nutshell. One of the reasons why it's often implemented if you just want some quick nasty sorting method for just a few numbers. It's big O is n squared. So when we look at bubble sort, we would say it's time complexity. It's ON squared. Why have I done that? Okay, and you can always spot, and remember this is an approximation, it's not an exact, it just means in relation to n, the time taken to process is a square relationship. So every time we add another item to process, the sort time gets bigger. So one item, so like n and n squared, you can see how the relationship grows, and it's not good growth. Okay, so if we had another one, if we had another one, we get 16. If we have just 5, one more, the processing time, can you see how the processing time's getting huge? 6 6 is a 36. I'll keep going. 49. So it keeps growing. So this distance each time gets bigger and bigger and bigger. Okay, so n squared are not good once the value of n gets moderately large. So obviously once we get up to 10, we're talking about 100 units of time taken, whatever those units are, and we're not bothered about that. Okay, you can spot an n squared because generally they'll involve 2 loops, and you can see we've got 2 loops. The reason why it's an approximation, all this big O stuff, is because it depends on the data. If this was sorted and we processed it, we'd only run through once. So actually that would be ON. Okay, linear. But we don't know what the data is going to be like. The worst case scenario is n squared. That's if we get reverse data, which means we're going to run through every pass and we're going to do swaps every time. Okay. So if you're looking at an algorithm, they say estimate what you think the big O is. If there's 2 loops, you're going for n squared straight away. Okay. They shouldn't try and ask you to do the other ones because they're not as easy to spot by just looking at the structure of the code. Okay, right. So this was using a while loop. Now I did say, because I did, that we could rearrange this. So let me paste this into the chat so you got a copy of a bubble sort and you can compare it with yours. Although, to be fair, I haven't tested it, have I? So let me test it first. Let me put some comment in at the top to see how it works. So triple comment. So I'm going to put obviously performs bubble. Oh. So bubble sorts the provided list array to sort. Keep using sort and a list and array in interchangeable. Humans don't really know what arrays are, they know what lists are. Alright, so that's why I've done that. Right, I need to test this. Now luckily we've got our little show array routine from before, so I'm just going to comment out the insertion sort. Let's just see if it works. So I'm going to say search sort dot bubble, and I'm just going to give it the same array nums. Right, let's try running that and see what it does when it's finished building. OBS is nicking all the disk time, even though I've got SSDs on this machine. I haven't got any hard drives. Right, okay, so we had 12, 10, 6, 9, 6, 7. So this was with duplicates as well. But you can see it hasn't sorted properly. So I've got an issue somewhere. Okay. So how did the 3... It might be the duplication. So let me just get rid of the duplicate 6 and try run it again. Leave the 3. Oh, we had a duplicate 3. That was one. Yeah, so this bubble sort, if I run that again, so it's left the 2 at the end. So I've got an issue here. The 12 didn't go right to the end. So I've got something broken. So what I'm going to do is I'm going to do a little bit of debugging on this. So I am going to put, on my bubble sort, I'm going to put a breakpoint. So I can do that in a couple of ways in Visual Studio. I can either click here and put a breakpoint in, which I don't tend to use that much. Or I can be on the line I want to stop and do F9. Okay. I know what the problem is, but I just want to show it to you. Because it's me not understanding how C# works. Right, so I'll put a breakpoint on that line. So what will happen when I run this time, the code's going to stop. Yeah, you bang on, Matt. But let's just see see why we're getting that problem. Okay, so I've now got it to stop, and once I'm in single step mode, breakpoint mode, I can look at values. Okay, so at the minute, if I'm going to just press F10 to move on. I can just float my mouse over and I can look at the value. So I can see swapped is true. Okay, so I go into here, that will force, so that value is true still. Forces the loop to happen because a while loop happens while a condition is true. So we go in here. Now, I'm now setting up and I say no. Okay, so start at no and do a comparison. So I'm going to go into this. It checks to see if I is less than process length. So process length is 6. So as long as I is less than 6. So what was the length of my list? My list had 8 items. So let me just go back to my whiteboard to try and illustrate this. So I've got 8 items. So I've got an item at position 0, 1, 2, 3, 4, 5, 6, 7. That's 8 items. So I want to do that pair, that pair, that pair, that pair, that pair, and that pair, and that pair. Okay, so I've got to compare the last two. So I want to generate that first number, remember? So I want to be able to generate 0, 1, 2, 3, 4, 5, and 6. And this is where I got my -2 from. 6 is 8 minus 2. So that was my logical thinking about it. Okay, right. So it should go up to 6. Now let's have a look at my code again. So process length is 6. So that's right. That's right. There's nothing wrong with that. But I'm saying I is less than. Now, 6 is not less than 6. This is a classic thing that they can put in a question and ask you why something's wrong. Okay, where we've got a boundary value. So 6 is not less than 6. 5 is. That's why it's stopping one from the end. Okay, so what I've got to be careful of is how a for loop works. And you have to be careful if you get given an algorithm that's written for a standard way of writing a for. Normally, you would include the value that's at the top of the loop. But the way that standard C language for loops work, because we always use this less than, you can actually change this. You could say less than or equal to, so I could fix it by going like that. But the standard way of doing a for loop is to say less than, because it works with our length list. So actually, we can fix this by saying -1. So that we're then saying, so I'm going to restart this and just check that it's going to get up to 6. So I'm going to restart the whole thing, get to that line, and see what it thinks process length is going to be. So in this case, I'll go through, and I'm just stepping through. We get to here. It says, as long as it's less than 7. So let's go back to my little example. And you can't, unless you can picture it in your head, you're better off just writing some stuff out. So 6 is less than 7. So it's going to run up to that. Okay? Because 6 is less than 7. So go back to my code. And I'm now going to kill that breakpoint and just continue running by just clicking up here and say, I can press F5 as well. But I'm just going to click continue and see what my output is this time. Or is it going to just crash? Let's just carry on again. I don't know why it did that. Right, now this time you can see the 12 is at the end. That's a good test of a bubble sort, is that if you put the biggest number at the start, you know it's going to get to the end. So if it doesn't get to the end, it gives you something to start exploring. And it will usually be to do with that. So as Matt said in the chat, yeah, it should have been process length -1 because of the way I did it. Now, the problem is, if you were doing it in another language, a non-C based language, you might have something like this. So if you was doing it in OCR pseudocode, or what they would consider, you might say this. You might say for I equals 0 to 6 to do this one. So actually 6 is 8 minus 2 because you're including that. So in general, if you see a for loop like this, it's inclusive. And it's something we've got to be aware of, because the exam board might write for loops like this in their pseudocode. Okay? But when we write that in C#, if you literally just did the same thing, you would be dropping one value. So you can fix it either way. If you want to keep it with the same number, you can just say less than or equal to. So I'll prove that by just editing my code. Okay, so if I go back to that -2, and if I put less than or equal to and then run it, you'll see that this works as well. But I don't like doing that. There's only rare occasions when I'm doing that, and you can see it sorted it properly. The only reason I might do that is if the logic of this makes more sense. But in general, no, that makes more sense to keep it with just the less than. Okay, so that is my bubble sort. So I've got all that. I have tested it. I couldn't just say it worked. Okay, you do wonder in some circumstances whether things don't get tested properly, and that's why we've got software that's buggy, because someone just went, oh, it'll work. It was so simple. You don't look at it. There's only about 5 lines of code. There's nothing to test, but you always have to test. Okay, so that's a good example of testing, where the logic sounded right, but it wasn't implemented right. It was the implementation that was wrong. Okay, right. So we've got this sort algorithm that works, but I could. So I'm going to now that I've confirmed that works, I'm going to paste that into your chat, so everyone's got this if it lets me. Right, so I'll paste that in there. Oh God, what's it doing there? Oh, no, it's lost it. I don't know what it's done now. It won't show me what I've typed in. He's probably put it in twice. Yeah, put it in twice. Let me just edit that. Oh dear. I don't know why the chat goes so funny when you're viewing it in the Teams windows. Yeah, we don't want it twice. Let's just delete the first one. Right, so that's one you can. Oh, it's really screwed up now. Should be 2 braces after that. Right, okay, so that is hopefully working copy. That's the worst bit of copy paste I've ever done in my life. Right, okay, so that's the standard bubble sort. But I did say that we could, if we want something to happen once at least, and we have got that process here, that we can rewrite this using the do while. So what I'm going to do, I should be able. Let me open. Let me do it. New horizontal. That's it. That's what I was trying to do. Right. Okay. So I have now got. I'm just going to zoom the windows back so I can see the code, or you can see the code. I don't need to see the code. Right. I'm just going to take the bubble sort, and I'm building it in program so I can build it out of the way, so I can see the bubble sort of the other side, so I can see side by side the difference between these two. Right, so instead of doing this like it's a bit bodgy, I'm forcing the loop to happen. So I'm going to get rid of that, and I'm going to say do instead. So this is what we call a do while loop. So it forces the code. The test for the end of the loop is at the bottom. So I would say while not swapped. So it changes the logic around, which is why we always tend to use a while loop. Okay, so hang on a minute, what's it moaning about now? Expected a semicolon. Of course you did. Right, so what I've got is I'm in the loop. So I haven't got to actually set this to any value outside. Oh, what did I press? I'm just going to create the variable outside. So I'm saying, right, okay, we're going to do this once. So all this happens at least once, and then we check to see if we swapped. Okay, so I'm still, all the rest of the mechanism is the same. So I'm going to now check. I'm going to call this bubble do, which is quite a good name actually. And I'm going to just check it works by you calling that one instead. It probably won't work now. Oh, got an error. Why have we got an error? Oh, I can't see. Glasses someone. What's it saying? Search sort. Oh, because I've got search sort on there. Yeah. It's in this because it's in my program class, so I don't need the qualifier on the front to say what class it's in. Right. So I've got it in Bubble Do. I run it again. See, the errors there are there to help you. They're not there to say you're rubbish at programming. They're there to say you've done something potentially not correct. Right. That hasn't worked. Okay. So what I want you to try and do is the logic sounded sound, but why have I got a 10 at the start? Now I know why I've got a 10 at the start, because it was the first swap I did. But it's like it's gone through once and then stopped. Okay, so right, I'm going to end the session there. So I want you, and this is a skill that I'm going to try and build up with you lot. I want you to get this working. So I'll put this in the chat. I've called it Bubble. I'll change its name to Bubble Don't Work. Right. You're not allowed to put the while back. So I want you to use this mechanism. So we run through once and we check at the bottom. And it might actually, in fact, no, let's just, if I do that, let me just, oh, I've got to change that to Bubble Don't Work now. Hang on. It is too easy to fix. I should have given you something a bit more complicated to do. When I've gone through and explained quick sort of merge sort, I might give you some broken versions of those. And if you can fix those, then you're doing good. Right, so you can see that what it is, it's the logic of it. Okay, so the reason I was wrong, I had while not swapped. Well, actually, that's stupid, isn't it? So it should have been keep doing it, do while something is true. So it works the same as a while loop, and you mustn't ever confuse this with a repeat until loop, which is sort of the opposite of the do while, which is a bit awkward, really. Repeat until doesn't exist in C# or any C-based language. They're all of this format. So it's sort of like a while loop, but you flip it on its head so that it sort of happens once at least. Okay, so do while will always happen once, and then your condition will kick you out of the loop or not. A while loop can happen no times because you test the condition before you get to the loop, and that's the key consideration. So you can see that generally they are pretty much the same. They've got the same number of lines, slightly different behavior. Okay, no version is better than the other version. They both perform the correct logic, and that's all we need to do. We just need to perform the correct logic. We do sometimes have to worry about efficiency. I don't know why it does that sometimes. I don't know why I'm floating around. I just don't. We do sometimes have to worry about efficiency, but in this case, it's just good enough for us to implement the algorithm in the manner it's intended. Okay. Right. Okay. What I want you to carry on doing is have a look at this bubble sort, the two different ones I've done, which I might now rename does work. Does work. Have a look at both of these. So I'll paste this into the chat as well. And what I want you lot to do for our next lesson is on. We're in week 1, aren't we? Right, our next lesson is on Tuesday. Okay, so what I'm going to do is I'm going to give you a little test on this on Tuesday. So it's going to cover serial search. It's going to cover, let me write this down and then I can screenshot it and put it in the chat. So test on Friday. Is going to be on serial search and binary search. And what I'm going to do is I'm going to give you some broken programs to fix. So all of the things that you're going to get, I'm going to give you something and you've got to fix it. Okay? And it's going to be on bubble and insertion sort. Oh, why's my, I think I need to change the tip on my pen. So this is going to be fixing broken code. Now, what these are not going to be is you hack away on the computer getting it to work. I want you to try. Did I say Thursday, Oliver? I can't remember. Hang on, let me stop recording.